A huge explosion, a blinding blast of whiteness, then a tall mushroom cloud with nothing but desolation. They all come from the smallest unit of matter, atoms. Einstein's famous equation, E equals mc squared, says that energy is mass times the speed of light squared. This c squared is large enough for even atoms to cause such devastating explosions, but only if their masses are to be converted into the form of energy. And so, a way to unlock this energy was the process of nuclear fission for the first atom bomb. Unlike nuclear fusion, a neutron triggers the nuclei to break in this process, converting some part of the mass into energy. The radioactive uranium-235 isotope, which has extra neutrons in its nucleus, was chosen for this process, since it was heavy enough yet was more prone to break than others. First of all, to avoid any pre-explosion, the scientists placed two chunks of uranium isotopes separately in their subcritical mass, a mass not enough to sustain the reaction. When detonated, the explosive propels one chunk to the other, reaching the critical mass, a mass enough to sustain the reaction. That is when a loose neutron comes into contact with a uranium-235 isotope to make it into a uranium-236 isotope. This unstable isotope then divides into barium and krypton, converting mass into energy while releasing 3 free neutrons. These neutrons go further to sustain this chain reaction. As a result, a huge amount of energy, which Einstein equated as the mass times the constant c squared, explodes before the eyes of the doomed mortals. Perhaps the modern Big Bang has come.